equal to set of all real numbers. So now they are talking about a set which is all the real numbers, not excluding anything. So even 0 will be there, negative numbers will be there, positive numbers will be there, and even the numbers between them will be there, right? So now they are asking if star is a binary operation and star is denoted like this. If I take a star b is a plus b plus ab. That is how they are denoting this star. Then which of the following are true? They have given 3 statements and we have to identify if they are right or wrong. So first one is a comma star is a group. So let's see if it is a group or not. And how can we test whether a set with an operation is a group or not? The same procedure. So first of all we have to check if it is a algebraic structure, and then check if it is a semi group, and then check if it is a monoid, and then check if it is a group, right? So it has to be a algebraic structure first, then semi group, then monoid, then only we can say if it is a group or not. If it fails to be any one of these, then it fails to be a group, right? Fine. Now let us, so I think you know how to put this set representation, right? So it is the set of all algebraic structures, and then set of all semi groups, and then set of all monoids, and then set of all groups. Got it? So if you have to enter, if you have to say that if something is a group, then it has to satisfy all these properties. If it doesn't satisfy any of these properties, then we cannot put it inside. Let us say it didn't happen to be algebraic structure, then I cannot put that anywhere here. Therefore it cannot be a group like that. Okay, fine. Now let's see this. So they are saying that a star b is defined like this. Then we should say whether it is semi group or not. Now first one is algebraic structure or not. So in order to test whether it is algebraic structure or not, the property that we should test is closure. So what does it mean? If I take two real numbers a, b, and if I apply star, then the result in this case is a plus b plus ab, right? So the result also has to be real numbers, which means if I take two numbers a and b from the set capital A, then the result also should belong to the same set capital A, which means the result also should be a real number. Now according to this expression, if we have a and b as two real numbers, definitely this expression is going to be a real number, is going to give us a real number, right? So definitely it is closed, there is no doubt in it. Right, because it is just a simple addition and multiplication. When you just add and multiply, we are never going to get imaginary numbers, we are going to get definitely real numbers, right? So yes, it is closed, and so we can say that it is algebraic structure. And the next one we should see is whether it is a semi group or not. Now how can we test a semi group? The property that we should satisfy is or check is associativity. So what does associativity mean? We have to check this. If I have three real numbers a, b, c, and if I apply the operation star, then it should happen this way. This should be equal to a star b star c, right? So it should happen something like this. So now let's evaluate the LHS and then the RHS. Now let us see LHS. Now how to evaluate LHS? A star b is nothing but this one, right? So a plus b plus ab star c. Now you can consider this entire term as, let's say, some x. Okay, now it is in form of x star c. Now what is the expansion for x star c? Then it should be x plus c plus x into c, isn't it? Now in place of x, just substitute this. It is going to be a plus b plus ab plus c plus a plus b plus ab into c, right? That is left hand side. Fine. Now let's see the right hand side. Yes, you can expand it and then get it to a short form if you want. Yeah, if you want we can even do that. Let's see that. Now this is going to be a plus b plus c plus, we have ab here, right, plus we have ac plus we have bc plus we have abc, right? So we have single terms, and then two terms, and then three terms, so like this. Now the right hand side is going to be a star b star c, which means we have to evaluate this one first. Okay, so how to evaluate this one first? B star c, we have to expand it. A star, what is b star c? It is b plus c plus bc, right? And now you can substitute this one as y. Now you can think of this one as a star y. Now what is a star y? A plus y plus a into y. Now you can put in place of y this expression and expand it. Then what do we get? A plus, what is y? B plus c plus bc plus a into b plus c plus bc. Then what do we get here? A plus b plus c plus ab plus bc plus ca plus abc. So we got the same thing, right? So left hand side happened to be right hand side, and so it does not matter either if you associate this b with the left side operator star, or you associate this b with the right side operator, the ultimate result doesn't matter. Therefore we can say that star is associative. Since star is associative, we can say that it is semi-group. And the next one is, we should test whether it is monoid or not. How can we test whether it is monoid or not? The property that we should test is whether it is going to have an identity element. So what is identity element? See this. Now I am testing for monoid, which means I should test for identity element. So what is identity element? If I have an element A, and if I apply star with an element E, then if we get A for all A, which means for every real number, for any real number, if you take A and if you apply the operation with that identity element, then we should get back the same element. Then we call such an element as the identity element, right? So here we are supposed to find out what the identity element is. Okay, now let's see this. Now this is nothing but A plus E plus AE, isn't it? By the definition of star, I am expanding it. That should be equal to A. Now what does it mean? You can cancel it out. Then E into 1 plus A is equal to 0, right? So what does it mean? So A is some real number, right? It need not be minus 1. It can be any real number. So for any real number, if you are going to get E into 1 plus A equal to 0, it definitely means that E is equal to 0, which means E equal to 0 is going to act, or 0 is going to act as identity element for this operation. So what does it mean? You can take 0 and you can apply star with any element, and we are going to get the same element. If you want, you can test it. For example, if I take the number 1 star 0, then what should happen? 1 plus 0 plus 1 into 0, which is nothing but 1. See this. So you have taken some number and you have applied star with 0, we got the same number. You can take any number and you are going to get the same number. That is why 0 is acting as an identity. Since you have an identity element, this particular we have satisfied this constraint called monoid also, right? So it is algebraic structure and it is semi-group because it is already algebraic structure and it is satisfying the property of associativity. Now it is already semi-group and it is satisfying the property of identity element, and so it is monoid. Now we have to test if every element is going to have an inverse, right? So how to find out? So last one is group. So how can we say that this is a group? Only when it is already monoid and then all the elements are going to have inverses. So the last one I should check is for the inverse property. Okay, so let's test it. So what is inverse? Let's see here. So what is inverse? Now we are going to have this element, let us say A, and if I apply star operation with its inverse, let us say A inverse, then I am supposed to get the identity element. Then only we call such an A inverse as inverse, right? So we already have a element A, and then A inverse is one more element, and we are applying this star. What does it mean? I am expanding this A star A inverse. It is going to be A plus A inverse plus A into A inverse is equal to 0. Why 0? Because identity element in this case is 0. Okay. And now if you observe this, so A inverse, you can take it as common, 1 plus A is equal to minus A, right? Now what does it mean? A inverse is equal to minus A by 1 plus A. Therefore, for every element A, the inverse is given by this root, this formula. Now we should show that if A is an element, then the inverse of it will also be present in the set of all real numbers. If A is a real number, because here we are talking about set of all real numbers, right? So you have to take any real number and you should show that the inverse will also be present in the same set. So let's see if it is possible, if it is really possible. In this case, it is possible. The reason is simple. Now if you have taken you take any number and you just substitute here, it will definitely have the inverse except one number, right? So what is that number? Can you guess it? So you can see that for A equal to minus 1, if you try to substitute minus 1 here, then what happens is it is going to be 1 by 0, which means it is going to be infinite. There is no real number called 1 by 0. Therefore, for the number minus 1, which is a real number, you cannot find a inverse which is present in the same set, because real numbers does not contain any number called infinity. Therefore, since even if you don't have inverse for one element also, we cannot call it a group. If it has to be a group, then inverse should exist for all the elements. Since it failed for one number, it doesn't matter, it failed. Therefore, it is not a group. Got it? So it doesn't mean that all the other elements doesn't have the inverses. All the other elements will have inverses. Only element that doesn't have inverse is minus 1. And even if you don't have inverse for one element also, we should not call it as a group. Therefore, the maximum property it has satisfied is monoid. So we can say that this A comma star is a monoid. It cannot be a group. Only thing it failed is it doesn't give the inverse. Therefore, we can say that it is not a group. So let's see this statement 1. A comma star is a group. It is false. It cannot be a group because of this small property, right? And the next one is the identity element with respect to star is minus 1. No, identity element with respect to star is 0 here, not minus 1. And the last one is the inverse of element 2 is minus 2 by 3. Yes, it is true, because inverse of an element A is minus A by A plus 1, right? Therefore, inverse of the element 2 must be minus 2 by 2 plus 1, which is nothing but minus 2 by 3. Yes, it is true. Got it? So the statement 3 is true. 1 and 2 are false. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.